Welcome to G Fun Facts Online. We often think of evolution as a straight line, a constant march forward where life gets more and more complex. But what if that line could bend? What if evolution could hit rewind? Today, we're diving into the Lazarus effect and reverse evolution, two phenomena that prove life's story is far more flexible, and frankly, stranger than you can imagine. We're talking about species that return from the dead, and traits that reappear millions of years after they vanished. First, let's talk about the Lazarus effect. The name comes from the biblical story of Lazarus, who was raised from the dead. In biology, it refers to a species that disappears from the fossil record, is declared extinct, and then, millions of years later, is found alive and well. These errant zombies, they're masters of hide and seek. Their reappearance is a shocking reminder that the fossil record isn't a perfect history book, but a very incomplete one. The most legendary of these resurrected species is the coelacanth. This was a fish known only from fossils, a creature believed to have died out with the dinosaurs 66 million years ago. Its lobe-like fins made it a critical link between fish and the first animals to walk on land. Finding a living coelacanth would be like finding a living T-Rex. And in 1938, that's almost what happened. A museum curator in South Africa, Marjorie Courtney Latimer, got a call from a local fishing captain about an unusual catch. On the deck of his trawler, she found a stunning, 5-foot-long, pale blue fish with 4 limb-like fins. She knew it was special. She sent a sketch to an expert, J.L.B. Smith, who, upon seeing it weeks later, confirmed the impossible. It was a coelacanth, a living fossil, an echo from a time before mammals ruled the earth. Smith famously nicknamed it Old Forelegs, and spent the next 14 years searching for another, solidifying one of the greatest biological discoveries of the century. Then there's the Lord Howe Island stick insect, or as it's sometimes called, the tree lobster. This huge, flightless insect was once so common it was used as fishing bait. But when a ship ran aground in 1918, the black rats that scrambled ashore spelled doom for the insect. By the 1930s, it was declared extinct. Decades passed. In the 1960s, climbers on a nearby volcanic stack called Ball's Pyramid, a sheer, terrifying shard of rock rising from the sea, found a few dead specimens. This sparked hope, but expeditions found nothing. Finally, in 2001, a team of scientists made a dangerous climb at night, suspecting the insects were nocturnal. There, clinging to a single shrub on a 60-degree slope, they found a tiny colony of just 24 individuals. It was the entire surviving population of a species once thought lost forever. Today, a captive breeding program at the Melbourne Zoo has brought the rarest insect in the world back from the brink. New Zealand also has its own Lazarus story with the takahē, a large, flightless bird with brilliant indigo plumage. Hunted and its habitat destroyed, the last confirmed sighting was in 1898. It was officially extinct, but a local physician, Dr. Jeffrey Orbell, refused to believe it. He'd heard strange bird calls in the remote Murchison Mountains and was convinced they belonged to the takahē. For years, people dismissed his belief, but he persisted, and in 1948, he led an expedition back to the area. There, in a secluded valley, he and his team found them. The takahē were alive. His discovery launched one of New Zealand's most successful endangered species programs, and the bird's population is now slowly recovering. The list keeps growing. In 2005, a rodent found in a market in Laos turned out to belong to a family thought to be extinct for 11 million years. It's been called the coelacanth of rodents. In Australia in 1994, a park ranger stumbled upon a grove of bizarre trees with bubbly bark in a remote canyon. They were woollamii pines, a species known only from 90-million-year-old fossils. And Australia's mysterious night parrot, a bird not seen alive for over a century, was officially rediscovered in 2013. So why does this happen? It's all about the fossil record. Becoming a fossil is an incredibly rare event. Most dead things get eaten or decay. An organism needs to be buried quickly in the right kind of sediment, under the right chemical conditions. This means our fossil record is incredibly biased and full of gaps. A species doesn't have to be extinct to disappear from the record. It just needs to have a small population or live somewhere that isn't good for making fossils. This creates what scientists call a ghost lineage. Often, after a mass extinction, a few survivors will hang on in small, isolated pockets called refugia. These are stable environments, like a deep-sea trench or a protected mountain valley, where life can ride out global chaos for millions of years, completely hidden from the fossil record, waiting for the world to become hospitable again. But the story gets even stranger. It's not just entire species that can reappear. Sometimes, individual traits can come back from the dead. This is the world of reverse evolution. The idea isn't that a bird devolves back into a dinosaur, but that a species can lose a complex trait and, incredibly, re-evolve it later. This flies in the face of a long-held biological rule called Dallos' law, which stated that evolution is irreversible. The logic was that the complex genes for a lost trait would decay over time, making it impossible to rebuild. But modern genetics tells us something different. It seems that the genes for a lost trait often aren't deleted. They're just switched off. The blueprints are filed away in the organism's genetic code. This genetic toolkit is highly conserved, and if the right mutation comes along, it can flick the switch back on, and an ancient trait can reappear. Take frogs, for instance. The common ancestor of all modern frogs lost the teeth on its lower jaw over 230 million years ago. But one species, named Gastrotheca guentheri, has them. It re-evolved true, functioning teeth on its lower jaw. Scientists believe this was possible because frogs still had teeth on their upper jaw, so the entire genetic machinery for making teeth was maintained. A simple regulatory change likely allowed this ancient program to run again in a new location. Another incredible example is found in salamanders. Many amphibians go through a free-living larval stage, like a tadpole. Some salamanders evolved to skip this stage, hatching as miniature adults, a process called direct development. This was thought to be a one-way evolutionary street, but genetic analysis has shown that some salamander species that have a larval stage actually evolved from ancestors who had lost it. They managed to bring back the entire, complex larval life cycle that their ancestors had abandoned. Perhaps the most stunning case involves sex itself. Asexual reproduction is common, but it's often considered an evolutionary dead end because it lacks the genetic shuffling of sex. Orabatid mites are ancient lineages that have reproduced asexually for millions of years. But studies have shown that some species within these asexual lines have re-evolved sexual reproduction. This means the complex genetic toolkit for making males and performing meiosis was preserved, dormant, for an unimaginable length of time before being reactivated. So what does all this mean? The Lazarus effect and reverse evolution completely change our view of life's history. They show us that evolution is not a simple march forward. It's a dynamic process of gain, loss, and sometimes regain. These phenomena prove that our fossil record is just a glimpse into the past, and that life's genetic code is a vast archive of its own history. Genes and developmental pathways can be silenced rather than deleted, holding the potential for ancient traits to re-emerge when conditions change. Evolution isn't an engineer building from a perfect blueprint. It's a tinkerer, messing around with the parts it has, repurposing old tools in new ways. These resurrected species and re-evolved traits are a powerful testament to the resilience of life, reminding us that extinction isn't always the final word, and that hidden in the genome is an echo of the past that can become the innovation of the future.